Assalamualaikum and salam sejahtera. My name is Muhammad Alias bin Mamat and my matric number is 21566. So let I introduce to our group member first. Water is the important thing that we need to use in our daily life. But the problem is how can we ensuring that the quality of the water at good and safe condition by not contaminated by any substance that can affect our body. Okay, so the water pollution can be caused by the urbanization, climate change, and industrialization. So for today, we will discuss in our group to how can water analysis can be such as important tools to what we can say that to improve the quality of the water to use in our daily life.
Yeah, Assalamualaikum. Today we are going to present about case study about underground and drinking water contamination in Chandigarh, India. So the main objective of this case study is to investigate the quality of water and monitor the level of various parameters in the drinking and underground water sample of Chandigarh and the nearby region. The method used to study the quality of the water in this investigation is thermoscientific trace 1300 GC or gas chromatography coupled with thermo TSQ 800 triple quadruple MS.
Okay, so from the investigation that's conducted, they have the pollutant such as industrial waste, like heavy metals, chemicals, and organic compounds from the factory that built near the underground water, and they will just let the waste into the water. Okay, and then for the product also from agricultural runoff, like fertilizer, pesticide, and pesticide that's used for the plants. Then when the rain, the water will flow into the underground. Okay, next is the sewage and wastewater. That because in Chandigarh, India, they have inadequate sewage treatment. So the water cannot be treated from the newest technology. Okay, and last one is solid waste disposal. Like from house to house, they will just throw the waste like bottle plastic, and so on. And when they throw it, it will affect the underground water.
Okay, so for now, I will present about the data analysis for this study. Case study. There is a lot of parameters that has been used to indicate that the water in this Chandigarh India area has suitable or not to use in daily life or as a drinking water. So for the first parameter is the temperature. It can easy to say all of the source of the water sample for the tap water, tube well, and hand pump was found to lie in range 25 to 30 degrees Celsius. For the pH parameter, the pH value of the most tap, tube well, and hand pump water sample collected for this report were found to be within the acceptable range. of 7.5 to 8.5 as per the guideline set by IS, or you can say that Indian standard 10500. So the next parameter is BOD. BOD was measured as an indicator of the strength of the waste in the water sample. The study found very low BOD values, suggesting that the water sample had no organic pollution. When the BOD value of the water sample ranged from 0.2 to 2.2 milligram per liter, which an average value of 0.77 plus minus 0.552 milligram per liter. The value are significantly lower than the permissible limit of 3 milligram per liter. So for the next is DO. The parameter that indicate the presence of the oxygen in the water, which is essential for the survival of the aquatic organism. The DO value of the water sample collected from the tap, tube well, and hand pump range from 5 to 7.5 milligram per liter, which an average value of 7.03 plus minus 0.51 milligram per liter. These values are within acceptable range of DO, which is 4 to 10 milligram per liter for drinking water, and capable of supporting aquatic life for not severely polluted. For the EC, or electrical conductivity, the measure of the water ability to conduct the electrical current, which is influenced by the presence of the dissolved ion. EC, or electrical conductivity values of the water sample range from 243.86 to 1545.66 micro as per centimeter, with an average value of the 774.15 plus minus 318.52. The value are within the acceptable range for the drinking water, indicating that the water sample do not have excessive material content or salinity issues. So for the pesticide parameters, the analysis for the presence of the endosulfate hexachlorocyclohexane, ES or SCS, as a pesticide was conducted in the water sample. However, all the samples shown the level below the detectable limit (BDL), indicating the absence or very low concentration of this pesticide.
Okay, next I will explain about the other various parameters such as TDS, or known as total dissolved solute, where TDS represent the bicarbonate, chloride, and sulfate salt of calcium, magnesium, potassium, and sodium in the water. The permissible limit for TDS in drinking water sample is up to 500 mg per liter, and most of the water sample observed had TDS below the prescribed limit. The TDS in the study area range was from 120 to 556 mg per liter, with mean value of 322.44 plus minus 88.30 mg per liter, which is it state that it was less than 5% of the sample exceed the limit of 500 mg per liter. And for some value were slightly higher than the prescribed limit. They were not significantly elevated, indicating that the water is suitable for drinking, and it was advised to boil the water before the user consume it. And the last parameter that used to investigate the sample of water is a total hardness, where the total hardness of water, which influenced by the presence of calcium and magnesium salt, was measured. The permissible limit for the total hardness, which is 300 mg per liter. The collected water sample range from 100 to 340 mg per liter, with an average of 173.87 plus minus 49.28 milligram per liter. And with the about 98% of the sample had hardness value below the prescribed limit, indicating that most of the water was within the acceptable range. However, at 16 HP point, it was found that to fall in very hard category, and local authorities marked the hand pump rate to indicate the issues. So that was the various parameter that used to investigate the water sample in different location.
Okay, from the research, we found some of the best way to prevent the crisis, which is our suggestion is the treatment of domestic surface water. Implement effective waste management system to ensure proper disposal of industrial waste, household waste, and sewage. This include establishing recycling program, promoting responsible waste disposal practice, and enforcing regulation. And our next suggestion is regular monitoring and testing. We allow for timely corrective action. By monitoring and testing, we will establish a comprehensive water monitoring, and this will assess the quality of underground and drinking water source. This help identify potential contamination. So for our last suggestion is that we strict industrial regulation to prevent release of harmful chemical. Enforcing stringent regulation for industry to control the discharge of pollutant into water sources. Monitor and regulate industrial activity to prevent the release of harmful chemical, heavy metal, and pollutant into the environment.
Okay, so next is what is the best water treatment can be implemented? First is coagulation and flocculation. Since the study found significant concentration of pharmaceutical, personal care products, pesticides, and industrial chemicals, coagulation and flocculation can be employed to remove suspended particles and some organic contaminants. The addition of coagulant and flocculants followed by sedimentation or filtration can help in reducing this contaminant. The second one is filtration. Given the presence of various emerging contaminants, including pharmaceuticals, personal care products, and industrial chemicals, filtration methods such as activated carbon filter can be effective. Activated carbon has the ability to absorb organic compounds and remove taste and odor causing substance. The third one is disinfection. To eliminate potential pathogen and ensure the safety of drinking water, disinfection is essential. Chlorination, UV disinfection, or ozonation can be considered. Chlorination is a common and cost-effective method, while UV disinfection and ozonation can offer additional benefits in terms of disinfection and removal of certain organic contaminants. Lastly is reverse osmosis, RO. It can be employed to remove dissolved salts, heavy metals, and some organic compounds, considering the presence of pharmaceuticals and industrial chemicals. RO can be effective treatment method to ensure the removal of these contaminants.
And lastly, for conclusion, to summarize, underground water in Chandigarh, India is not safe for daily consumption because the water having significant concentration of chemical oxygen demand, COD. This site was being used for agriculture purpose, posing threat to public health. To ensure safe drinking water, it is generally advised to rely on treated and properly tested water sources. So that's all from our group.
Last but not least, water analysis plays such as a vital role in the identifying the potential of the contaminant. So the application of this tool is highly recommended because the tools can ensure the quality level of the water.